All right, here we go, Chapter 6. In Section 6.1, we're going to talk about roots and radical expressions. Let's begin by reviewing the first three types of roots, square roots, and then we'll talk about cube roots, and then fourth roots. So, square roots. When you're looking at square roots, you're going to have a symbol that looks like this. There won't be a number out front, but what it's implied is that we're looking for the square root. So we're going to just imagine that there's a little 2 right there. Let's take the square root of 3,125. Well, the first thing I'm going to do is break down 3,125 by making a factor ladder. You might remember a factor ladder from middle school. So what's a prime number that goes into 3,125? 5, actually. 5 goes into 3,125 625 times. 5 goes into 625 125 times. 5 goes into 125 25 times. And then, of course, 5 goes into 25 5 times. And I'm going to stop when I get to a prime number here at the very bottom of the ladder. All right, so that's a factor ladder. Now, because I'm looking for square roots, I'm looking for groups of 2, because if I rewrite this as the square root of, 5 squared times 5 squared times 5, then I can cancel out a square and a square root. So again, I had one group of 2 5s and then a second group of 2 5s. The square and the square root cancel out, and my final answer would be 5 times the square root of 5, or 25 square root of 5. So that's a square root. Let's move on to a cube root. So when we're looking at cube roots, we're still going to have that radical symbol, but on the little tail of the radical, we'll have a number 3. So let's take a look at the third root of 3,125. I'm going to go back to my factor ladder. I'm not going to recreate this factor ladder, but because I'm looking for a third root, now I want to find groups of 3. I have one group of 3 5s. So I can rewrite this as the third root of 5 to the third times, well, I have 2 5s left over, so I'm going to write 5 squared. So again, I had one group of 3 5s, so that went right here. And then the third root and the third power canceled out. Third root and third power canceled out. So I'm left with 5 times the third root of 5 squared, or I could write that 5 times the third root of 25. All right, so that is the third root of 3,125. Lastly, let's talk about a fourth root. Now, are we going to work with roots higher than the fourth root? Yeah, maybe, but we can do it. Same rules apply. So the fourth root of 3,125, going back to my factor ladder again, and you might be able to guess this, but I'm going to look for a group of 4 5s. So can I make a group of 4 5s? And actually I can. So I'm going to rewrite this as the fourth root of 5 to the fourth power times, I had 1 5 left over. I had 1 5 left over, so I can just call that 5, or 5 to the first. So 5 to the fourth came from this circled group of 4 5s. Fourth root and the fourth power cancel each other out. And then my final answer will be 5 times the fourth root of 5. And I'm done there. I don't need to rewrite anything at all. So that's how we find roots higher than just a square root. A factor ladder is really helpful. When you're making a factor ladder, just remember to always use prime numbers. What's a prime number that would go into whatever you're working with? All right, so let's talk about a property now. So the first property in this chapter is called the nth root of an nth power property. The nth root of an nth power property. And this is kind of a big one, so make sure you have this written down. If you are looking for the odd root of a negative number, if you're looking for the odd root of a negative number, you're going to end up with some sort of a negative answer. Or in other words, you know what? It is okay to take the odd root of a negative number. You're probably thinking, huh, that's new. Because last semester I drilled into your brains that if you're taking the square root of a negative number, this is like no solution, or this doesn't exist. In calculus we say DNE, does not exist. You cannot take the even root of a negative number. Let's take a look at a few more examples. I want to do 3 examples, and I'm going to leave you with 3 to try on your own. In example 1, let's take the square root of 16x to the 8th power. And then in example 2, I'm going to write all my examples down here. We're going to take the third root of a to the 6th, b to the 9th. And then our third example, we're taking a look at the fourth root of 81, x to the 4th, b to the 20th. X to the 4th, b to the 20th. So starting with example 1, if you have color coded like I did up here when I was doing my factor ladders, I'm going to stick to that same color coding. So square root is red. Okay, I'm looking for just a square root here. So I'm trying to think about, can I rewrite these numbers as squares? And I can. Check this out. 16 is like 4 squared. And then x to the 8th is like x to the 4th squared. So do you see what I did there? I took 8 and I divided it by 2, and that's where I got x to the 4th squared. Now the square and the square root cancel out, and my final answer will just be 4x to the 4th. Done. Nothing's left underneath that radical. The squares and the square roots canceled. Nothing's left underneath the radical. You know, I don't have anything over here that didn't get canceled out. So I'm good to go at 4x to the 4th. All right, then let's take a look at the third root of a to the 6th, b to the 9th. So again, third is the magic number here. 3 is the magic number. I'm going to write a to the 6th as a to the 2nd to the 3rd. And then how am I going to rewrite b? I want something to the 3rd. How about b to the 3rd to the 3rd? 3 times 3 is 9. 2 times 3 was 6 on the a. Third root and the third powers cancel each other out. And so my final answer will be a squared b to the 3rd. Dunzo. That's it. All right. Here we go for last example, 4th power. 4th root, 4th powers are going to cancel each other out. So, what do you know about 81? What do you know about 81? I know. I think it's time for a thought bubble. First thought bubble of the chapter. Woohoo! 81 is 9 squared. And I know that 9 is 3 squared. So I can rewrite that as 3 to the 4th. Yay, I like that. That was good thinking. I promise you that by the end of the month, you are going to know 81 is 3 to the 4th, like the backside of your hand. Okay, so I thought through 81. 81 is 3 to the 4th. Let's rewrite this. Oh, and you know what? I'm going to go back here real quick because, ooh, I just made a fatal mistake here. If you are talking about anything other than a square root, you need to make sure that you are always including that. So notice how I was better this time than I was in the second example. You always have to be transferring that root. If you don't have the correct little root sitting on the tail of your radical, you're going to get the problem wrong. Okay, so anyway, 81 is 3 to the 4th. X to the 4th is just x to the 4th. B. B to the what to the 4th? Are you good with 5? The 4's cancel, 4's cancels, 4's cancel, 4th power, 4th root. I'm left with 3x b to the 5th. And that's that. Okay, so those are some pretty basic examples. How about taking a couple more minutes here on your own, and I'm going to leave you with 3 problems to try. So you try these. The third root of negative 27. You try the 4th root of negative x to the 12th. And you try the square root of 50 a to the 6th. I'm even going to give you one hint before I sign off. One of these doesn't exist. All right, good work. I am happy to be back at, it with Chapter 6. Exponents, radicals, powers. Whew, we are in for a fun time.